Hey guys, we're going to look at some applications of these radicals with distance and midpoint. We'll look at the formulas and also kind of how we get them. So thanks for watching. Don't forget to like, comment, and subscribe. The Pythagorean Theorem is kind of named after Pythagoras, even though we know that the ancient Egyptians knew about it and other ancient cultures, I suppose. Very common in construction. People use the 3, 4, 5 triangle, a Pythagorean triple, because it's nice to help us form right angles. The truth is if you have a right triangle, then c squared equals a squared plus b squared. We're not really concerned with that second part, but if you like it, then look at it and love it. Okay, but in this case, my drawings aren't perfect either. I'm going to say that A is red there, and then B is purple, and these two create a right angle, and I'm trying here. And then we have what is called the hypotenuse, which is, it's the longest side for a right triangle, but it's opposite. What that means is that the right angle kind of points at it, right there, the hypotenuse. It's a big word. If you can't memorize it, then watch Key and Peele. All right, the red side there is called a leg, and the purple side, just to make it real easy to memorize and also to confuse people, is called a leg. Now again, you have to have a right triangle for this to happen, though. Okay, and A is a leg, B is a leg, and then C is the hypotenuse here. Okay. Back in ancient Greece, or it was Greece, I think. If you had nothing to do on Friday nights, you would go with all the math nerds and you'd hang out. Yeah, right. And you would eat tiny triangular shaped sandwiches that no one likes, but back then they loved them. And you would talk about math all night long until the wee hours of the night, until you couldn't talk about math anymore until the next meeting, right? The two legs there make up the right angle. The legs will always make up the right angle, always, which is how we know it's not a hypotenuse. Well, with the Pythagorean theorem, and it used the word hypotenuse in this one, so even though it did not show the right angle, which I suppose it probably should have, well, maybe better than I'm drawing it anyways, since it used the hypotenuse, we kind of get to assume that this is a right triangle, which is kind of nice, right? And these two are legs because they make up the right angle. Also, it did tell us to find the hypotenuse, so whatever. Okay, so I have the two legs, 2 and 7, and I need to square those and find their sum, and that should equal the hypotenuse squared, which is the longest side, okay, or the side opposite of the right angle. This isn't too bad. 2 squared is 4, and 7 squared is 49. So I'm going to add those, and that should be c squared. And 4 plus 49 is 53, which again should equal c squared. But I don't want c squared. I don't want the hypotenuse squared. What I want is just the hypotenuse. So to solve this one, I will be square rooting both sides. So the square root of c squared is just c, and now I've got the square root of 53. Didn't give us any units on that. It said it wanted the exact value, so we're not going to round either or plug this into the calculator. We're just done. Find the length of the leg x. Enter the exact value, not a decimal approximation. So again, we're not plugging this into the calculator, other than maybe finding squares, which we may need. So the x value is a leg now because it makes up that 90-degree angle, which they didn't show but probably should have. And that value is x. The other leg is the 8, which makes up that right angle again. But the hypotenuse we have on this one is 18. So I'm going to square my two legs, add them together, and that should be my hypotenuse squared as well. All right, well, let's square this business. We got x squared plus 8 squared is 64, and that equals 18 squared. All right, well, to solve for x squared, I'm going to subtract 64 from both sides. And to solve this now, because we want the leg there, we're going to square root both sides. So that gives me just the length of the leg, which would be the square root of 260. Now we do have to be careful though, because 260 is a kind of a large number right there. So I just want to see and make sure there's no perfect squares in its factoring, okay? For example, I guess I'm looking at 13 and 20. There we go. 20's got 1 and 4 and 5. There's my perfect square right there, right? So in other words, 260 really is 4 times, what did I get, 13 times 5, so 65. Which would be 2 times the square root of 65, right? So I just split that up and I took the square root of 4, which is 2. And again, it didn't give us units, but that looks like it's as far as we can simplify that. 17-inch laptop has a screen that is 19 inches tall. How wide is the screen? I'm not too familiar with these, but I understand that laptops are measured by the diagonal length right here. Very good. So that means that would be 17 inches. And it tells us that it's 9 inches tall, so we got 9 inches right here. And what we want then is the length of this, or the width of the screen right here, which we'll just call X. Now this is right, hopefully we can see that this would give us this right triangle right here. So I've got a leg that's 9 inches, and then I've got another leg that's X inches, and then I also have the hypotenuse, which is 17 inches. So again, I'm going to square my two legs, add them together, and it should equal the hypotenuse squared. So 9 squared is 81, x squared is, well, x squared. I'm going to add those together, and I should get 17 squared. Now just solving for x squared, I'll subtract 81 from both sides. And then finally solving for x, I'll square root both sides. And it did want us to find the exact answer, so that's the square root of 208. Now let's just look at 208 and see if we can factor this out. Looks like it should go into 4 and 52. 52, is that another 4 number? Yeah. 4 and 13. So I really could have split it up into 16 and 13. So the square root of that would have given us 4 times the square root of 13. Now this one did give us the units, so that's in inches. That would be the exact answer. If I were to plug it into my calculator, 14.4 approximate answers. Didn't really say where though, so here's what I got. There we go. We have an approximation and also an exact value for it. The Pythagorean Theorem is good because we don't really need to memorize the distance formula, which I'll show you guys here in a moment. But, for example, just looking at this graph, let's just find 2 points and we'll figure out what the heck we're doing on this, okay? So, if you guys give me a point. So, these 2 points, 0, 0, and -3, 1. So, the nice thing about pretty much all sets of 2 points, and we've seen this with slope as well, is if I kind of make a stair step out of that, like this in purple, then I can also make a right triangle out of it. Now, yeah, my line should be straighter. I apologize for that. And could we find the lengths of the 2 legs on this, right? Because we're looking at the right angle right there. Yeah, we should be able to. This length is 1, and this length is 3. Okay, so to find the length of the line between these 2 points here, or the distance between them, which is what we're looking at, then I'm going to take the 2 legs, 1 and 3, I'm going to square those, add them together, and I should get the hypotenuse squared. And that's 1 plus 9, which is c squared. So 10 is c squared, So the square root of 10 is c. And yeah, I just skipped some parts for that just to demonstrate that. So the question is, we got the two legs on that, right? Let me see if I can find brighter colors. Like this leg right here. And the question is, how do we find the distance between values? Well, we would use subtraction, right? So all I did is I did 1 minus 0 to get this one. And then over here I did, how far is it from negative 3 to 0, which is the same as 0 minus negative 3. You could do negative 3 minus 0, right? Which would give you negative 3. We just don't look at distances in terms of negatives, which is why we have that as a positive. Now, if I made this a negative 3 here in the Pythagorean Theorem, once I square it, it's going to be positive 9 anyways. So it's not going to matter whether I use the negative 3 or the positive 3 for that. But subtraction is key for finding distances. This. Okay. So we have 2 points. And if I wanted to find the distance between x1 and x2, I would subtract those. And that distance would give me a leg. Okay, so this set of parentheses represents one of the legs. The distance between the y's, which again would be subtraction, would be the other leg. And if I squared both of those and added them, then I would get the hypotenuse squared. So all I got to do is square root both sides of that to get just the hypotenuse, which is the distance. All right, this one's kind of already set up for us, right? But if we were to find the distance on these, we'd be looking at the points 6, 5, and also 9, 7. And that it's the same thing as asking what the distance is between these 2 points. Now this one, we want the answer to 3 decimal places, so we are looking to estimate this one. And so, just evaluating this, right? I mean, some of you guys would just plug this directly into your calculator and be done. So we're going to have some squared values. 6 minus 9 is negative 3, and 5 minus 7 is negative 2. Now, again, with that negative stuff, it's going to go away with the squaring of these values anyways. So I got 9 plus 4, which is the square root of 13, which is 3.606. So the distance between those 2 points, rounded to 3 decimal places, 3.606. Find the distance of the line segment below. You can enter a number to the nearest hundredth, or calculate the number by entering the formula as you would on a calculator. All right, so we will round this to the nearest hundredth, 2 decimal places. We'll use the formula on this one, because we've already seen how it works on a graph, right? So I've got my 2x values that I'm going to add together. Oh, I got to subtract them, I apologize, and square that. And then I'm going to add the y value, subtract it, and square that value. So the x values, just to acknowledge that, this point here is negative 5, negative 2. And then my other point here is at 2, 2. So I'm going to take my x value, well, start with negative 5 going to 2, and then my y value, negative 2, going to 2. And we'll take the square root of that action. And we got negative 5 minus 2 is negative 7. Of course, we're squaring that. And we'll add that to negative 2 minus 2, which is negative 4. And we'll square that as well. Of course, we're taking the square root of all that stuff. So negative 7 squared is 49, and negative 4 squared is 16. Let's add those together. Square root 49 plus 16, 65. Seems like we've seen that before, but it wants us to plug it into the calculator anyways. Of course, I guess that's what the calculator gives us. If it wanted the exact value, it would do the square root of 65. I don't think that can be simplified. All right, find the distance between these 2 points. Now this one didn't give us a graph, and well, 15 and 20 are kind of big. If you wanted to still graph it, you could, but we'll go ahead and continue with the formula on this one. So I got my x values subtracted squared, and my y values subtracted squared. If I add those two together and square root that, then I should get the distance on this thing. So I'm going to look at this one as my 1 values, and this is my 2 values. Again, the order of those isn't going to matter, okay? So I really got 5 minus 6. And I also got 15 minus 20. So I got the square root. We're going to square those and add them. So 5 minus 6 is negative 1. We're going to square that. And 15 minus 20 is negative 5, which we are also going to square. And we'll add those two squares. Negative 1 squared is 1. Negative 5 squared is 25.
Negative 15.
Then I've got the square root. 1 plus 25 is 26, which again I could put into my calculator. If the homework asks for the exact value, you could have the square root of 26. Otherwise, I don't know. Didn't say even where to round it, so 6.403. That's about all I want to write.
You started.
What the heck? Distance formula again, since I guess we're using it all the time now. So again, this is just setting it up, this minus and squared and addition stuff, okay? So that all I need to do now is to fill in the values. So I'm going to do, that's a 3 for my x, and then the other one's a negative 2. And then my y's, I need to keep these in order, so I got negative 4 minus, in this case, 0. Now we can't forget that minus negative is going to make that plus. So now I've got the square root, and we're going to square those and add them. 3 plus 2 is 5. You can put parentheses on that if you want, but I definitely need parentheses with the negative 4 minus 0 is negative 4. So I got the square root, and I'm going to square those now. 5 squared is 25, and 4 squared is 16. So I end up with the square root of 25 plus 16, 41. Yeah, this one is, I was looking at the wrong problem, right? There we go. On the exam, I would accept either of these, but it looks like the homework wants the decimal. Well, it's kind of showing both, so maybe either. Midpoint's kind of hard to show on a graph because it's averages, okay? Because if I were to take two values, let's say, I don't know, 5 and 10, and I said, what's the number? Not 10's a bad number because we had a decimal. Let's use 15. Well, it is 10. But anyways, if I said find the number right in between these, you guys could just find the value that's right in between them. Or you could find the average of the two, right? You could say, well, I'm just going to take 5 and add 15, and I'll divide that by 2. So, 20 divided by 2, there we go, which is 10, okay? So it doesn't matter if that was the y values or the x values, you just add the two together and then divide by 2, which is the average, the number right in between. However, if we were looking at a graph, gave me a couple easy ones on this one. All right, you could use the triangle on this, right? I mean, okay, we're going to connect the two. We want the midpoint. So I'm going to make a triangle on this just so we can kind of visualize what the heck is going on here. So I got the change in y's on this one, which I guess you could say I'm going up here. Doesn't matter, up, down, whatever. And I just want the exact middle of this line, okay? So we could see how long it is. There's 6, 7, 8, 9, 10. So from either end, to find the middle, I'm just going to go 5 units, okay? So 1, 2, 3, 4, 5. So this is the midpoint of that line. which would also be the average. And I can do it with the other line, so I'm looking for the midpoint between these two values. How long is this one? 1, 2, 3, 4, 5, 6. So half of that is 3, right? Which would put me at this point right here. Well, I just want to know where those two values intersect, and it should be on that black line if I'd drawn it correctly. Right there, right? Which this one has no decimal values at -3, -1. And that right there would be considered our midpoint. Find the midpoint of these. We'll start by using the formula. So we got our x values, we're going to add them and then divide by 2 because it's an average. Same with the y values, we'll add those two and then divide by 2. So I got my first point. The x value is -4 when the y value is 0. And the second point, the x value is 0 when the y value is -2. So just simplifying my numerators, it's still over 2. I've got -4 plus 0, which is -4, and 0 plus -2, which is -2. And I can simplify those fractions. You could just plug it into a calculator, right? -2, -1, bam, done. Now, if you wanted to, you could use a graph just to confirm that, but that's pretty good. They actually did give us a graph on this one, which is great. So let's use the graph instead on this one, even though you could use the formula. If you did, you'd just want to acknowledge the values of these points. We got 3, 3, and also -1, -1. Oh, the slope on that is very nice. In any case, I have this triangle right here. And I'm going to go up 1, 2, 3, 4, so my midpoint would be 2. And then for the other one, this one's 1, 2, 3, 4 as well. So the midpoint is at, the x value is 1. So that gives us this point right here. Give it a different color. At 1, 1. Midpoint, done. The midpoint of AB is at -4, 0, so that is the midpoint, okay? If A is -2, -10, then we've got to find the value of B. So in the formula, right, everything is divided by 2, we're adding the values. Let's say we're going to do A as our first value, so that we got -4 and 0. And then B, we got its x value and then its y value. Now, we do know the value of the midpoint at, wait, I used the midpoint. Let me change those out, okay? I apologize. The midpoint is -4, 0. I need to use A, which is at -2, -10. That's better. But the midpoint does tell us that these values are going to equal -4 and also 0. It really just gives us two equations to solve, okay? So let's start with our first equation. So when I solve this equation, it's going to give me the x value for the point B. So we would start by multiplying both sides by 2 first. And I got -2 plus x equals -8. Add 2 to both sides. And x, that's why we should use a calculator, right? Is -6. Thank you. All right, now we got the other one. And now we'll solve this one. So I'll multiply 2 on both sides again. And I got -10 plus y equals, well, 0. Then I'll add 10 to both sides. I'll try to do this one right. Y is 10. There we go. So when I look at the point B, the x value is -6, and the y value is 10. That's it. And, you know, we could confirm that, right? -2 plus -6 is -8 divided by 2 is -4. And then -10 plus 10 is 0 divided by 2 is still 0. So that gives us the actual values of the midpoint.